This is the second video on volume of right prisms, and we're also going to look at some applications. The volume of what's called a right prism, now we've gone over what prisms are, so see previous videos or see your notes. Of right prisms, remember we consider a prism, just very quickly, of something with the constant cross section as we go up or across or along its main axis, and that cross-sectional shape is always the same. But there are other sorts of prisms, and I don't mean cones or pyramids and things like that, because they are not prisms, as we've discussed in the past. I'm talking about things that are like this. They are prisms as well, but they are not right prisms. The cross-sectional area is constant, but the base and the height are not at right angles, and therefore it's not a right prism. So that angle there is not a right angle, whereas on these ones it is. As you look at the cross-sectional area as you go up, you've got basically the same shape, and the height and the base are at right angles. So that is a right prism. An important main point to consider here is the expression or the formula that will give us the volume of a right prism. It's written here, it's very important. V for volume, volume equals A times H. A is the cross-sectional area, the area of the cross-section, which is constant or it stays the same. And it's multiplied by the height, which is the height which is basically the distance along the main axis. Okay, so on this shape, the main axis, let me try that again. The cross-sectional area and the height. The cross-sectional area is the blue section on this one. Remember, it's constant the whole way through, as I just said, and the height is the distance from the base through to the other end of it. So that's the length along the axis, the main axis, and that's called the height. And on this shape here, it's the height there, or you could draw it there like with that red arrow. So that's what H has to be. It's not a slant height or any other sort of distance, and it's not the distance across. Okay, it is not that, it's the distance from one end to the other along the main axis. That's what the height is called. So volume is the cross-sectional area times height. In some easier questions, the cross-sectional area is given. So we'll look at some soon like that. I'll show you 3 examples coming up, and the second example will show you when A is given, the cross-sectional area. Other ones, like the third example, you have to work out the cross-sectional area, and then you multiply it by the height. Usually the height is given. On some of the more difficult questions you need to work out the height as well, but usually A is something that you have to work out, and H is given. The most common 2 shapes we will be dealing with are the prisms rectangular prism, triangular prism. Sometimes they're called cuboids, the rectangular prisms. But you can see that with the rectangular prism, probably the most common shape of all we deal with, the volume is still equal to the cross-sectional area times the height. However, the cross-sectional area, if that's not given to you, you know that it's length times width. So we have that blue zone here on this diagram is the cross-sectional area. It's constant as we go up the height. So that makes it length times width times height, or abbreviated as LWH. So that's an important one to take note of. We then have our second one here, triangular prism. This one's a little bit more complicated, but you're expected to be able to master this at this level. Always start with the same formula, volume equals cross-sectional area times height. Here we need to think about the next line. Here you might notice that there are two heights, and I've talked about this briefly in previous videos with this shape, because we have seen the triangular prism before. Notice how there's a H1 and a H2. That's deliberate because they are usually different. H1 is the height of the triangle cross section. So you might recall that the area of a triangle from previous work is base times the perpendicular height divided by 2, or half b times h, where h is that perpendicular height, which must be at right angles to the base. It's important to remember that. Therefore, that is a different height to the prism's height. The prism's height, remember, is that same height. It's the length along the main axis, just as we saw previously in this video. So let's look at the part here, that's the cross-sectional area. To work that out, we have to work out the area of a triangle. So it's half base times the perpendicular height. Please do not use the slant heights, that will give you the wrong answer. They are longer than the perpendicular height. So it's half times the base times the perpendicular height of the triangle, which is called H1 here, times H2, which is the height of the prism. Some examples. First one is a very simple example. It's probably perhaps year 7 approximately, or even earlier on, because it is broken up into cubes of 1 by 1 by 1. So each of those cubes has a volume of 1 cubic centimeter, and there are 1, 2, 3 of them. Okay, so that is 3 times 1 cubic centimeter. It's 3 lots of 1, so therefore the volume is 3 cubic centimeters. So we'll write that in there. Second example is still fairly simple. So we start with our formula, volume equals A times H, cross-sectional area times the height. If you look at it, the cross-sectional area, which is that bit of a love heart shape, the blue shape, is constant all the way through. If you slice that along, look along the length of its main axis, then you slice it as you went down, you'd have that constant cross section there. So that is a right prism. So we have the area that is given is 10, and the height there is 5. So it's a simple matter of 10 multiplied by 5, which is 50. The units, remember, for volume are cubic units, centimeters cubed, because we have squared times centimeters to the power 1, which makes centimeters cubed to the power 3. Lastly, we have another prism. This one is a triangular prism. It has a constant cross section. You can tell by the front surface here, and the middle and the rear, all the same triangle. So that is a right prism, and the volume is cross-sectional area times the height. Now if we look at it, we can straight away see the height is 6, because that's the length along its main axis. Even though it's sitting down, and that doesn't look like it's going up or down, that doesn't mean it's not the height. You could stand that up on its base, and then the 6 centimeters would be the height. It's still the height if it's laying down. So we know that H equals 6. But what about A? Well, as we saw above, that's the area of a triangle. So half times B times H1 times H2 is what we're going to use. That's a half of the base is 4 of the triangle. The height, the perpendicular height, yep, you can see the right angle there, that's clearly the perpendicular height, that's 3. And H2 is what we just spoke about, the 6. Okay, so 6 times 3 is 18. 18 times 4 is 72. Half of 72 is 36. So we have 36 centimeters cubed. for our total volume. Remember, volume is cubic units. Now you're ready. Now that you've got your notes, you're ready to practice some mastering.